maybe if you didn't know how to solve it, it seems like better than not. This particular problem, it's very intentionally something I did not want you to be able to do with a calculator, so I could not see giving credit for a calculator answer when it was so clearly not appropriate. However, I did get another kind of answer that caused me to have to think a lot. A number of people wrote down a factually true statement. They said secant of 23 pi over 4 is 1 over the cosine of 23 pi over 4. Now, I have to tell you that I am extremely sympathetic to a student reading a problem and based on what the question says, it says find secant 23 pi over 4 exactly, to come up with something that was not something I expected. And maybe that was the case here. And usually, as I say, I'm willing to overlook, you know, if I want something and I don't describe it exactly and someone gets confused, I'm usually very sympathetic. Again, the question was find the secant of 23 pi over 4 exactly. And I was about to start, you know, doling out points for this, and I remembered a comic I had seen a number of years ago. I'm going to show you. This is kind of math humor, I guess. So this is how it starts. It's called Algebra Genius. Find x. Right? So what is the answer? It's right here. Factually correct. Right? Now, if you were a high school algebra teacher, would you mark this correct? I guess what I'm getting at is, it's hard for me to understand if I said find this in this context. Now, I grant you, maybe some of you sincerely did that, but it's hard for me to think, you would think that that's what I was looking for. It's correct, it is exact, but you did a little, and I gave you a point for showing me that you knew the definition of the secant. But I wanted to say that in contrast, you know, usually I give students the benefit of the doubt. Earlier today I spoke with someone in class during office hours and I was moved a little bit. So if I wasn't moved enough yet, if by some odd chance you think strongly that, you know, you were really confused, you can come during the break or after class and maybe you'll move me further if it benefit you and any other student in that situation. Okay, I wanted to mention one more thing about the quiz. An error I made in correcting. I don't know if it applies to you. But on problem number 8, someone pointed out to me where they had shown the offset as plus pi over 8. Is that right? Yes. And in fact, I marked that wrong, but it should have been correct. I was thinking it's really plus this value over here. And I'm sorry, I'll bring it up during break. I will correct it and give you full credit. Just something to take a look at if you haven't. Okay, I will now open this up to any questions, general questions you have about the quiz.
Can you go over this problem just shown?
Yeah,
Be happy to. Which problem?
the same one you were.
Oh, okay. All right. So, get some scrap paper here. So, I think you can go about this in various ways, but I think the first thing you want to notice is the period. The period here goes between 5 pi over 8 and pi over 8, the difference being 4 pi over 8 or pi over 2. The period of the tangent function where b is 1 is pi. So we want our b to be something that converts pi to pi over 2. And if you remember, the bigger the b, the smaller the period. The smaller the b, the bigger the period. So b must equal 2. I think that's the first thing to notice. Well, that's the second thing to notice. The first thing is this is a tangent function. I think that's very important. So let's take a look at what we have so far. We have our f of x equals sum a times the tangent of b, which is 2x minus the phase, which we don't know yet, that's c. Okay, so our c at this point is pretty easy to find. It's going to be minus this value here. So what is that value? Well, it's clearly right between pi over 8 and 5 pi over 8. So it's going to be 3 pi over 8. And let me write this again. Now, at this point, as far as I'm concerned, if you've got these values, you've got full credit, regardless of what you said A was. But if you were concerned about what A is, you could plug in 0. F of 0 is what? Well, from the diagram, it's 1. That's A tangent of, well, simplifying this, it's minus 3 pi over 4. And if you do a little work, you'll find that the tangent of minus 3 pi over 4 is 1. So A must be equal to 1. I took no deductions for any other values of A, but that's how you would determine it. Right? If this point were 2, then you can see immediately that A would have to be equal to 2.
Can you again go over how you're supposed to get C?
C is the phase shift. So if you want to subtract, the tangent would normally go through 0, 0, but instead it goes through 0, what did I say, 3 pi over 8.
But
so that's C.
4 pi, right? Never mind.
Question. Wouldn't you see your C be different if you imagine that the tangent actually moved left instead of right?
Yes, yes.
So there
So
could be
if instead of moving from here to here, in which case it's a minus, you move from here to here, it's a plus. And then it becomes whatever this point is, which What did we decide that was pi over 8?
Yes.
Yeah, so it can also be tangent of 2x plus pi over 8. That's the error I mentioned earlier.
Yeah, I got.
They're actually, if you think about it, there's an infinite number of values you can put in for the phase shift, right? Because it's periodic, right? If you move it over, the function still repeats in both directions. Okay. Yes?
So would you accept that pi over 8 answer?
Yes, if you see it on your thing and it's marked wrong, you want to bring it up and I'll give you those points. That was my error. You know, I have approximately 40 papers times 12 problems, 500 problems.
Thank you.
And, you know, I'm just like you guys. I want to do it as quickly, although carefully. Usually I'm pretty careful. But I make mistakes, so don't feel like that's not in the cards. Okay, questions on any other problems? Other problems? Other questions?
Can you go over 11?
11, okay. Well, I can't really just go over 11, can I? Okay, so the first thing I want to find for this set here, set of data, is the maximum and the minimum. The maximum is 1 and the minimum is -9. The amplitude is then 1 minus -9 over 2, or 5. The midline is going to be the max plus the min divided by 2, so that's -4. And then how would I find the period? Well, I have to look at the data here, find some place it seems to repeat. So I can say, well, I could start at 0. So -4 goes down, 1 comes back up, goes to -4, but now it's going down. Oh, I'm sorry. -4 goes up, gets to its peak 1, starts coming down. I get to -4 again, but it's still going down, hits the bottom, comes back up, now we're at -4, and then it starts going up again. Okay, so kind of between here and here, this -4 and this -4. So what's that period? So 1, 2, 3, 4, 5, 6, 7, 8. So the period is 8. Pick up my sleeve. Okay, are we good on that? Because that tells us a lot, all right? I'm just going to jump ahead and point out that let's see here. I could do this as a sine or a cosine. I happen to see that its peak is at 2, right? That's it, you know, where the 1 is. So I'm going to use a cosine. What's my A value? That's the amplitude. I'm going to kind of sneak in plus -4 or -4. That's my vertical offset. And so my period is 8. Okay? The period of a cosine is 2 pi. Right? So what's my B value? Right? It's going to be 2 pi over 8, or pi over 4. So that's my B value. And all I have to do now is find my C value, which, as I pointed out, I know that the cosine starts at 2, positive 2. So I can just subtract 2 here. That's my C value. Now you could have done it with a sine, and you'd come up with a different phase offset. also.
That's not clear for me how you got C minus 2.
I'm sorry?
It's not clear for me how you got C minus 2.
Okay. Let me see if I can draw a picture. So here's where my cosine, actually, why don't I draw this the way it actually is instead of just some random thing here. The midline is at minus 4. Right. The amplitude is 5, so that's going to go between 1 and minus 9. So I'm just going to, this is 2 and this is 10, so that's going to be my period, 8. And the cosine is going to start here at 2. 2, 3, 4. It's going to hit bottom in the middle and then back up again. So at 2 and 6 is where it's going to go through the midline. Now, the point here is this is where the cosine starts.
Ah,
All right? It's offset 2 from 0. So we subtract 2. If you offset in the other direction, add.
or if you have a sign, then the sign is
Well, the sign
At
starts at the
-4.
midline.
yeah, it starts in the
Let's
middle.
just take a look. Where is this at the midline and going up? Right?
From 0
It looks
From
like.
0.
or 8. 0 and 8.
Oh, yeah. Okay. I guess that'd be simpler, wouldn't it?
Yes.
Yeah,
It's
sine 1
simpler.
is more simpler.
It'd be simpler to say pi sine of pi over 4 x minus 0
57.
minus 4. That was, I think, some people put that as the answer. That was perfectly fine too. Right. Any other questions? Chet?
For number 5, can you go over like marking the axes?
I'm sorry. What was the question about 5?
Can you go over marking the axes?
Sure. So, 5 is a sine function, but it's only modification from your default sine function is it's pushed up 1, right? So its midline is 1. Its boundaries are 2 and 0. So you would start it at 1. Its period is 2 pi. So I know it's going to go between, there's no phase shift here, right? So I can just start it at this point. Its period is 2 pi. All I marked here on the axis was pi and pi over 2. That was enough. If you like, this is pi over 2, and this point is 3 pi over 2. And then I just draw in my sine curve. And you can draw more or even less. It's clear.
May we go over number 2?
Sure.
To show us exactly
Sure.
what we're looking for.
Okay. So we want to find secant of, what is it, 23 pi over 4. I would suggest the first obvious thing to do is to put this between 0 and 2 pi, right? So how can I do that? Well, 2 pi is 8 pi over 4. So I can take that out twice. I can take 16 pi over 4 out, and I'm left with the secant of 7 pi over 4. Now is a good moment to reflect on the fact that this must be equal to 1 over the cosine of 7 pi over 4. Okay, so now I want to learn what the cosine of 7 pi over 4 is. Well, there's pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5, 6, 7. Pi over 4, of course, is 45 degrees, so this is a 45-degree angle. It's also minus 45 if you like. And that gives me an isosceles right triangle. So I know the cosine of an isosceles right triangle is, of the 45 degrees, is 1 over the square root of 2. I should know that by now. And since what I really want is the reciprocal, this is just going to become the square root of 2. I think that's a good order to do things in. First reduce it or put it between 0 and 2 pi. And then reduce it to sines, cosines, and tangents, and then, for an exact problem, then take a look. Now, if there's no, look, we've only learned 3 angles that you can do this with: 30, 60, and 45. You could also do it with 90, 180, 270, but those are even easier. We will later in the class learn a method to get an exact value for some other values, but for right now, it's going to be one of these. You have to keep track of the sign, not S-I-N-E, S-I-G-N, right? Remember, plus plus in the first quadrant, minus minus in the third quadrant for cosine and sine, and then and so forth, plus minus and minus plus. That's what you have to kind of have a handle on. Okay. Any last questions on the quiz? You all should recall that I throw away the lowest score. So if you did poorly on this one, it can get thrown away and not really affect the grade. Or if you miss a class, that's happened. Okay. Next item of business. Are there any questions on the homework that was for? Yep.
31.
For today?
Yeah.
Okay.
Almost ready.
Will this go on to anyone? He was here Monday after class. It's a notebook. Doesn't have a name. Starts off solving piecewise functions, but it's got some. Oh, all right. I'm trying to sell, Okay, the speed trap. Is that the one? That's the one you're talking about, Mustafa?
30. Yeah, that one.
Speed trap?
Yes.
Okay. I haven't done this one yet, so you'll watch me struggle through it. I have no idea what a theodolite is.
Me too.
You do?
Me too, I don't know.
Oh, yeah.
It's like,
But it's unimportant.
it's
Yes?
like a transit. It's like a surveyor's transit.
Oh,
You know?
okay.
Yeah.
Yeah. That makes, see, I think I've heard that term before.
It's just this pretty much the same thing.
Yeah, surveyor has these, like a little telescope, and it's got, you
It's
can
got,
check the angle.
you do tangent, it's got like up and down and all.
Yeah, okay. It's not necessary to solve the problem. Okay. I'll draw their diagram here. And we have A, 66 degrees, B, which is a right angle, and C, and we have a hypotenuse of 500. It's used to measure the distance from a particular point, A, to a car traveling down a flat level road, BC. So the car is going this way down the road. 10 seconds later, the device measures the distance to the car and the angle of rotation, C. So they're saying that it took 10 seconds for the car to travel from B to C. And we want to know if it was speeding. So this is, you could just guess. You have a 50% chance of getting it right. Huh? The speed limit is 45 miles per hour. So we know it took 10 seconds. So really all we need to know is what's this distance here. Right? Find x. All right. So what trig function, see, and don't be bashful, don't feel shamed if you need to do this. Sometimes it helps to turn the diagram to some normalized way you're used to looking at it, right? See, I look here and I say, okay, so
Is this opposite?
I just rotated it, really didn't do anything. So if this is x, and this is 500, and this is 66, what's the trig function that relates them?
It's the opposite, right?
Opposite, right? So it's the sine, right? So I'm going to turn this back. So I have the sine of 66 degrees is equal to what?
O over H.
Opposite, which is
Opposite,
I'm calling
opposite
x,
over hypothesis.
500, right? Or x is equal to 500 sine of 66. Now that's the distance, but I want to know the velocity, right? So velocity is distance over time. So this is feet over 10 seconds.
9.1.
Now, of course, I'm going to get my calculator out in a second. But before I do this, keep in mind, I don't really want to know feet per second, right? I want to know miles per hour. Does anyone know how to convert miles per hour?
How many
Feet
feet
per
in a
second.
mile?
Hmm?
How many feet in a mile?
Well, there's, for anybody who's not from the US, this just seems like
Yeah, the
useless
second,
information.
second
It's like,
it's
what's wrong with this country?
60 second, 1 minute.
Centigrams. Celsius, I mean, come on, science, right? Right? But 5,280 feet in a mile, right? I'm just gonna jump here. It's a good thing to know that 60 miles per hour is 88 feet per second.
If I remember correctly, you should multiply by the 5,280 and divide by
Yeah, and you'll get this.
3,600.
All right. So this is feet per second. So if I divide by feet per second, which is 88, and I multiply by miles per hour, 60, I should get the miles per hour of this guy. All right. The rest is just, punching numbers on a calculator. Okay, so let's see. 500 sine, oh, wait a minute, what's my mode? I made a mistake on your PhD thesis. 66 times 60 divided by 10 times 88. 31. So is he a speeder or not?
No.
No. Okay, other questions on homework? Okay,
2042.
number 42. Evil Knievel,
Is that wrong?
you guys too young to know about Evil Knievel?
What's that?
So the thing is.
He was a crazy person. He started by, he would do this trick where he would ride a motorcycle in a big arena, and he would go up a ramp and go over buses and then come down. He didn't always come down nicely. And one of his claims was that he had broken every bone in his body. Well, I'm sure he didn't break every bone, but maybe all the major ones, right? He crashed a lot. And he would go over like 20, 30. So that was his career. But then one day he came up with this idea that he was going to ride a motorcycle over the Grand Canyon. He figured he just had to have a fast enough motorcycle, and he would go over the Grand Canyon, and then he wasn't thinking he could land, so he would have a parachute, a parachute. And he got a lot of people interested in this, and they put together a whole lot of money, and they started looking into it, and there was no way he was going to get a motorcycle to get him over the Grand Canyon. So he switched, and he says he's going to fly in a rocket. And I forget what happened. You can look it up on Google.
He's still alive?
I don't think he made it.
What was his last show?
He went down to the canyon.
He went down in the canyon.
Yeah, he went down to
Yeah.
the bottom. But it was a Snake River Canyon.
It was one of these hilarious media nonsense events.
But he got paid.
Oh yeah, he did this for money. Well, he figured he's risking his life, rocket could explode, the parachute might not open.
Yeah, but compared to the stuff he did like on the motorcycle, it was sort of like, it was very soft.
That's true, it was kind of silly.
The parachute, he came down very gently actually, but
Yeah.
the guy was like a rag doll.
Yeah.
Go on YouTube and look up his greatest hits, it's very painful to watch.
All right. But there's some mathematics in this somewhere. Okay, a special rocket was built for the stunt, launched off a ramp. The ramp was 300 feet in length and rose 200 feet. So let me see if I can draw that. 300 feet in length and rose 200 feet. Okay. Calculate the measure of the angle of elevation. I told you you'd need that definition, didn't I? The angle of elevation that the ramp makes with the ground. All right. So there's my right angle. This is the theta I'm looking for. And what's the trig function here?
Samson.
Well, we've got a hypotenuse and we've got an opposite.
Sine.
Sine.
So sine of theta is equal to 200 over 300, or 2/3. So what we want is theta is the inverse sine of 2/3. That's easy enough. No exact answer here. All right, so we'll just say 42 degrees. Close enough for Evil Knievel. That's part A. And then part B, the horizontal crossbeam is located halfway to the top of the ramp. Calculate the length of this crossbeam. Okay, I think what they mean is this. right? Now, I don't know how good your geometry intuition is. But if you think about it, if this is halfway from here to here, what's its relationship to the base? Does anyone know? This being the base. It's going to be half. Right? These are similar triangles, right? And a ratio of this length to the big height, is 1/2. You'll have the same thing here. So really what we want to do is find the length of B and take half of it. Well, how am I going to find B without sweating too hard?
Cosine inverse?
You could, but
Oh, Pythagorean theorem.
Pythagorean theorem, 300 squared minus 200 squared, and then we have to remember to divide by 2, because cross, right? By the way, there's simpler ways we could do this if we were doing it by hand, which is how we would have had to have done it like 30 years ago. But right now, it's no reason. Square root of 300 squared minus 200 squared divided by 2. So, again, about 112 feet across. So the bottom's like 200 feet across. Oh, yeah, that makes sense. Yeah, and it makes sense that the bottom is 220, 224, and you think, well, that's kind of close to the height, isn't it? Yeah, and the angle is kind of close to 45, so it all makes, this isn't how to solve it, this is just how to look at it and go, does the answer make sense? It often helps to do that. Okay, any other questions on this homework? No, okay, good. I'm not quite done with homework. I had when I was correcting the homework last night for the previous section, I think is 8.7, there wasn't very much of it. So kudos to those of you who did give me some homework. But I got the distinct feeling that many of you didn't really kind of get, I mean, you know how to do the inverse function, but you didn't really get a feel for what some of these problems were asking. And in particular, I want to look at problem number 50, which is the Ferris wheel. Another Ferris wheel problem. Get this on the screen because it's not visible to me here. So they give you some function for the height, and they want you to figure out at what angles does the height of this reach 110 feet on the interval from 0 to 720 degrees. That is, the Ferris wheel is going to go around twice. And, okay, this doesn't look too hard at first. Let's just do the obvious thing, and which isn't too hard. 246 sine of theta minus 90 degrees plus 296 equals 110. 10, and I'm sure you're all pretty okay with algebra. I hope you all are. And so we're just going to do the algebra thing where we run this in reverse, right? We subtract 296 from both sides. All right, what is that going to give us? That's going to give us 180, minus 186 is 246 sine of theta minus 90 degrees. Now we're going to divide both sides by 246. I'm going to leave that for later when I get my calculator out. I want to get rid of the sign, so I'm going to find the inverse sine of both sides. Theta minus 90 degrees equals the inverse sine of 286 over 246. And finally, I'll add 90 degrees to both sides. So I get 90 plus the sine inverse of minus 186 over 246. Okay, so I look at that, and the only problem is they said something about on the interval from 0 to 720.
Professor, you can raise it.
Oh, sorry.
Can you zoom out?
Yeah, zoom out. Thank you. So immediately, I know that from 0 to 360, I'm going to find two values for the sine. I may have to move one of them over so it's positive, or maybe it's negative, but I add it to 90 and I get a positive. But, you know, this whole 0 to 720, it kind of throws me a little, and I want to be a little creative, and before I start popping the answer out, I want to get a feel for what's going on. And it turns out there's a nice creative way to do this with your calculator. Let's see, do I have this in here? 246 sine of x minus 90 plus 296. Okay, that's just the left side of the equation. Think of that as a function. I mean, you can do this in one equation too, but, and on the other side, I'm going to say, well, y equals 110. So now I'm plotting, you know, this, you know, the Ferris wheel's going around, so it's a sine wave. I'm plotting that line, and I want to make sure my window is set up right. Okay, I'm going from 0 to 720 degrees, and I just want to make sure my y is wide enough. Say how tall this Ferris wheel is? Doesn't, but put in enough room here. And I'm going to graph it. And the purpose of this is not to find the solution. You could. I'll even show you how. Just to get the feel for what's going on here. Right? So it looks like, it looks like pretty soon after I start over here, I don't know how many degrees this is, it's not too many, two equations cross. That's probably going to give me the first number that's going to pop out of that equation. And then it's going to come up and it's going to hit again. At that point, I start going into my 2 pi periodic function repeat, right? So I know if I can find these two values and just add 360 to them, I'll get my answer. All right, so let's pop back here. Now let's actually run this through. A little. So 90 plus inverse sine of minus 186 divided by 246, 40 point, I'll just say 9 degrees. Okay, that's one of the solutions. Let's think again about the sine function. Right, so I've got 40 degrees here. where's the other y gonna be? I'm sorry, that's not what I meant to say. Where else is this going to, hit the circle? Right?
180 minus it.
It's kind of over here, isn't it?
Oh, okay.
Actually, that's the value I just got, isn't it? 40, I did it backwards. This is where we hit 40.9, right? So it's also going to be at 40.9, right? That doesn't look right to me at all. Let's go back and ask the calculator. We've got a nice function here called calculate intersection. Oh, kind of in the right place. Let's move a little bug over. 319.
360 minus the common.
319. Okay, so that's my 40. There's my minus 40.9 plus 360, that's this value, right? So I've got two values, and how do I get the next two? That's the easy part. I just plus 360. Now, I mention this because I don't recall anyone turning anything in with all these answers. When the question asks for the solutions where we've got an inverse trig function, and they're not just looking for one, you might have to look around, you can use your calculator to help you kind of get a feel for it. Sometimes that's all you need, you don't need the right answer, you just need to know what does the answer look like. And what I'm trying to get at is, you want to be a little creative in math at times. If you're stumped by something or you're unclear, you want to get more of an intuition of what's going on. Now, it's not easy to learn how to do that, but like many things, you have to kind of practice it a little. Which is why I give you homework to practice it. I think you should take it. I know some of you take it very seriously, and I appreciate that. But I know, since I'm not like grading it and giving you a score on it, I don't want it to be something where you feel like this is a test or a quiz. You've got to, that just gives students a incentive not to do it at all and copy somebody else's. Not that anyone would do that. So I really want you to think about, yeah, this stuff is hard and there are more fun things to do, like watch The Walking Dead and, play video games. But it's important. If you're gonna learn this, that's the way to do it. Just to focus on this. If you get stumped, bring in your questions. I did want to say one more thing about homework, and it's embarrassing because it's a failing of mine, but I think you're entitled to know it. The easier it is for me to read your homework, the more attention I'm going to get. If I'm like staring at it and I cannot make out what you're doing, I'm just going to go, okay, does it look like you did the right thing? But if I can actually see the answer, like put a little square around it, right? Then at least I can go, oh, didn't get the right answer, I can mark that, or I can look at what was going on. So again, I encourage you, I know not everybody was blessed with good handwriting. I was not. That's why I learned how to type stuff in when I was in grad school. Isn't that beautiful? How do you do that? You need a couple things. There's a great program that I use called Math Equation or something. Anyway, if you're going to go on in math or science, you want to do that. Okay, I think that's it for now. We're going to take a break, and then we're going to learn a little bit some more math, some fun math. So take 10 minutes, come back. Got things for me to correct. Yes.
I was here with a section, some like what's going
Discover the law of sine from one of the diagrams used earlier. Divide this triangle into two right triangles. In this right triangle, the altitude is A sine C. And in this one, it's C sine A. So A sine C is C sine A. The same reasoning gives us two more equations. The three equations can also be written this way. This set of equations is called the law of sine. It tells us that in a given triangle, the length of any side divided by the sine of the opposite angles is constant. This constant ratio has a different geometric meaning. It's equal to the diameter of the circle passing through the three vertices. In a later program, we'll see why. Each equation in the law of sine relates four parts of the triangle, two angles, and two sides. So if we know three of the four parts, we can find the fourth. For example, suppose we know this side has these two angles. First, find the angle opposite the given side. Now, use the law of sines twice to get the other two sides. In this example, we know two sides and the angle opposite one of them. The law of sines tells us that the sine of angle B is equal to the ratio B sine A divided by A. The numerator represents this distance. If A is smaller than B sine A, the ratio is greater than 1, and there is no possible angle B. If A equals B sine A, angle B is a right angle. If A is greater than B sine A, there can be two possible supplementary angles B. And if sine A is greater than B, there is only one possible angle B. Finally, if angle A is greater than a right angle, there is at most one angle B. Now we know two angles and the side between them, and the problem is just like the first example.
If only we could learn stuff that fast. You could just sit here for like maybe 2 hours and you'd know the whole course. All right, don't panic. You didn't get 100% of that. Okay, so Monday I left off with a problem like this and I said, what are we going to do with this? Because dropping this perpendicular, this altitude doesn't really help much. And we need this new theorem known as the law of sines to attack this problem. So I'm going to go over the derivation a little more slowly, and I'm going to use a different, that's essentially the same mechanism. So we start with a triangle, general triangle, with angles A, B, and C, and opposite sides using lowercase a, b, and c. And we drop an altitude, which is, we're going to call h. So we note that for this triangle here, that the sine of angle A is h over b. And similarly for this other triangle, the sine of angle B is h over a. We then rewrite each of these. This one we write as B sine A equals H. And here we have A sine angle B equals H. But since these are equal, they're both equal to H by the, what do we call that? Gosh, I'm supposed to know this stuff. A equals B, B equals C, A equals C. Transitivity, thank you. I don't know why that didn't pop into my head right away. So we have B sine of A equals A sine of B, or as I often write it, sine A over A equals sine B over B. He described it as being the reciprocal of this, but either of them is acceptable as the law of sines, and you can use them either way. Now repeating what I just did with the height drop from, say, A, we come up with the fact that these are both also equal to sine of C over C. And that is the law of sines. In context to what we've done before with sines, which is we've constructed them out of right angles, this is quite surprising, I think, that now these trig functions don't just govern something in a right triangle, but they tell us something about any general triangle. Okay. And this, of course, is going to be quite useful for solving certain kinds of triangles. Okay. So let's go back to the original problem I described. We have a triangle, angles 48 degrees and 57 degrees. And the included side we know is 10. And we want to find the other parts of the triangle. So first thing we want to do is find the third angle, because we're going to need that to use the law of sines. The sum of these is 90, 105 degrees, so this angle has to be 75 degrees. Using the law of sines now, we can say that 10 over the sine of 75 degrees is going to be, I guess I should give these other sides names. So we'll just call them x and y. It's going to be x over the sine of its opposite angle, 57 degrees. degrees, which is also equal to y over the sine of 48 degrees. Okay, now it's just a matter of taking these two at a time. Right? If I take these two together, I get that x equals 10 sine of 57 degrees over sine of 75 degrees. And putting these two together, I get that y equals 10 sine of 48 degrees over sine of 75 degrees. And these are both expressions you can solve quite easily, calculate quite easily with your calculator. Okay, so that's a particular example from Monday that we call that angle side angle. Right? So now we know how to solve an angle side angle problem.
Oh, 1 second. Please. Please, just keep it 1 second.
I'm leaving it there. Good.
Yeah, but can you just explain to me? I just get confused. Is this cross multiply or what you have done?
Oh, how did I do this?
Yeah.
Okay, let me do this slowly. 10 over sine 75 degrees equals x over sine 57 degrees. You could cross multiply, but then I'd have x times sine of 75 equals 10 times sine of 57, and then you could divide.
Divide, yeah.
Right. But all I did is I said, let's multiply both sides by sine of 57 degrees. On this side, I get 10 sine of 57 degrees over sine of 75. And on this side, sine of 57 degrees cancels because I multiplied it on the top and the bottom. So I just end up with x. You okay with this?
Yeah.
Okay. All right. That covers one type of problem. When we look at SSA, I think you may recall I mentioned that we get a little more ambiguity here. Right? In particular, let's say we have 30-degree angle, and the side that's 15, and the other side is 10. Well, the problem here is that there are actually two different triangles that this could be. So let's look at how the law of sines would handle this. Right? So we start off with the sine of 30 degrees over 10 is now going to be equal to the sine of a missing angle, let's call that x, over 15. Right? Where is that angle? That angle could be here, or it could be here. So, all right, let's go ahead and solve. Sine of x equals, here again I'm multiplying by 15 on both sides, sine of 30 degrees over 10. And let's see, what's the sine of 30 degrees? It's a half, is that right? So that's 15 over 20, or 3/5. Sound right? I'm feeling like insecure, so I'm gonna. I'd rather show you that I'm insecure than show you that I'm stupid. Right? Check my mode. Yeah. Oh, okay. Now it's 3/4. All right. So the obvious thing to do is to find inverse sine. I'm sorry. Inverse sine of 3/4. Well, let's go ahead and do that. Okay, so get a principal value of 48 point, I'm just going to say 6 degrees. Obviously, that's this angle. Wait a minute, why do my notes say something totally different? No, guess they're wrong. Okay, so let's now take a look at this. We have a sine that is 48 degrees. This isn't working out right at all, which means that I'm going to have to try and fix this on the fly. Well, okay, when you can't do trigonometry, do geometry, right? If this angle is 48.6, then this angle has to be what? 48.6, because it's an isosceles triangle. So this angle just has to be what? It's the complement, right? So it's 180 minus 48.6, right? 131.4. Okay, now, the video pointed out that there are other possibilities. For example, we could have this situation. We'd say, let's say this is 60 degrees, and let's say this side is 10 and this side is 6, right? So what would happen if we try and solve it? I mean, we don't know this a priori necessarily. It's not a triangle, right? But what would the law of sines tell us? It would say that the sine of 60 degrees over 6 is equal to the sine of some new angle over 10, or, the weight of my hands here a little, x is the inverse sine of 10 times the sine of 60 degrees over 6. Now, you can almost guess right away what's going to happen. Let me just show you what 10 sine of 60 is divided by 6. It's 1.44. I'm not going to try and put that into my inverse sine function y.
It's bigger than 1. It's bigger than 1.
It's bigger than 1. Or could be less than minus 1 because it's bigger than 1. Anyone know what happens when you try and do that? You should find out. See what the calculator does, so when it does it on a quiz, instead of tearing our hair out, right? Error. Error means error. Domain means I plug something into a function that's outside of its domain. So something, of course, if one gets this, one wants to say to Did I do something wrong? Or maybe the problem's trying to tell me something. In this case, 1.44 is not in the domain of the inverse function. All right. Let's see. What else can we do with this? That's it. So we're going to do a little practice, and we'll go over them, and we'll be done for the evening.
Thank you.
We need a couple more.
For the last one.
Oliver just tried for help, right? Okay, everyone have one?
Yes.
Question?
I am not this person, you are this side of me. I am not.
Okay. That was before. Now sine is a function whose domain is all real numbers. Okay. Hand these out. Did Chetnak come back? Daniel. Sorry. It's right here.
He's here.
Pull up.
Yeah, so you don't need the multiplication.
Did you have the V value right?
I did. It was,
I'm trying to figure out why did I mark it wrong?
oh, because it had plus pi over 8.
No, that's why I put phase sign. Oh, I guess, you know what? I was looking, oh. It's okay. My apologies to you for disrespecting your good work.
That's all? That's all?
Yes, I'm not trying to gaslight you. You've been here all this time, right?
Yeah.
Because I looked up and I looked for you and I didn't see you. But now I do. You were hiding.
Third time he won. That's it. Yeah, it's like weird, like, I don't really understand. Twice, third time stop. Don't ask it. Yeah. How much you got the last one, the end of the end?
Okay.
No, I get it.
So, number one, what we got here? Anyone want to fill in here? We got A, B, little b is 14, B is 28 degrees, A is 37 degrees. Anyone want to know, tell me what C is? What the angle is?
27 about? I'm sorry, no. Angle C is 150.
115? Okay. So that's plenty of information to use the law of sines. What do we have for side A?
17.95. 17.95.
17.95, okay. And C, little c is
27.
27?
Yes.
You're right.
Okay, anyone get anything terribly different? That means you did get something terribly, no.
I don't know, we're good.
Okay, all right. Any questions about this? I mean, it's pretty straightforward. It's a really useful tool, all right? All right, let's take a look at number 2.
No?
Okay, here we have,
What's wrong? No. Tell me.
have a side angle, I'm sorry, angle side, so 23 degrees, 10, well, let's not be too,
Yeah, but the B side is up.
say 5. Okay, what did we find out about this?
And now
I guess
this
I'll
one.
just draw the line all the way. So, let's see, this is angle A, angle B, angle C. So do we have any other angles here we can determine?
No.
Just no? Something go wrong?
No.
Did everyone get no?
I got A equals 51.26 degrees.
Okay, which would make C what?
105.74.
74, all right. Now, I've heard two different answers. I've heard this one and I've heard no, which is a possibility, right? So the question is, which is it? Well, we know sine of 23 over 5 has to equal sine of A over 10, right? I'm running out of space on my messy, where am I here? So sine of A equals 10 over 5, that's just 2 sine 23 degrees, right? Now what's the sine of 23 degrees?
0.78.
No offense, I'm just being mechanical here. Times 2 is 0.78. So if I find the inverse sine of that,
You will get 50.
I get 51 point, well, close enough, right?
Wait, I got 51.16 as well.
Okay, well, typed something wrong or my calculator is off or something. Okay, so that tells me I've got 3 angles, so there's just one more side. This is an obtuse angle, right? It's greater than 90 degrees, even though I didn't draw it that way. What do I get for the length of the third side?
12.32.
12.32. Okay. All right, any questions about that? All right. So let's go to this final problem, which I had to, the first time around, with these numbers switched, there's no answer. Right? I mean, what does that look like? What does that look like in real life? Well, it kind of looks like this, where this side of the triangle is too long, given the angle here. You know, this is A and B. B isn't long enough to reach down. We don't even get a right triangle. So, but if I switch them, now I have this situation where I know I'm going to get 2 answers. Right? So does anyone have the opposite angle here for the acute triangle solution? 51? 51?
Oh, never mind, I got for the whole.
Not sure?
I did for the whole thing, I just didn't know. I
No,
didn't
alright.
put the
All right. So sine of 73 over 54 is going to be sine of x, whatever, over 63. So x is sine inverse of 63. Wait a minute. That's what I was doing before, wasn't
Yeah.
it? This can be switched. 54/63. Sine 73. What does that come out to?
0.82. 0.82.
0.80?
0.82.
Are you in radian mode? I want
The degree.
degrees. Can't see 0.8 degrees. Ah, could be.
Let's see. But
Let's see, 54 divided by 63 times the sine of 73. And then we want the inverse sine.
Yeah, that's
that's the sign. And the inverse will
That's
be.
what
I get 55 degrees.
Yes.
55.
Okay, so one version of this, the triangle, this angle is 55 degrees. And this angle here has to be its complement, so 135. All right, any questions? Okay, there's some homework. We'll get a little practice. You'll be ready for the next exam? Okay. All right, I'm here for at least the next 5 minutes. Do you have any business? Please come bring it up.
Go ahead.